mural in the maths department of this guy, Felix the cat. Why? Well, Felix the cat had this magic bag of tricks, and whenever he got in a bind, whenever he got in trouble, he just reached in his bag of tricks, pulled something out, tried it. If it worked, great. If it didn't, he would just reach in his bag of tricks and pull out another trick until he found something that worked. And that is kind of the spirit of mathematics. Sometimes you have to invent the tricks though, but in this case you don't. If you come along to any of my physical lessons, you quite often hear me say this old saying that isn't really used much these days: there's more than one way to skin a cat. And it is kind of a horrible saying, but it means that often there's more than one way of getting the right answer. And in simultaneous equations, you've got lots and lots of options for solving these simultaneous equations. And I'm going to use all of them to solve this set of simultaneous equations: x plus y equals 10 and x minus y equals 4. First way I'm going to do it, I'm going to convert these into the y equals mx plus c form, and that way we can solve them graphically, just visually, just by looking at them. So I'm going to take the first one, so x plus y equals 10. I'm going to take x away from both sides, and we're left with y equals minus x plus 10. The second one, x minus y equals 4. I'm actually going to add a y to both sides, and I'm going to subtract 4 from both sides. So y is going to be equal to x minus 4. So I've got two lines, y equals x minus 4 and y equals minus x plus 10. And then what would I do? Well, I can go to GeoGebra or to the calculator solver. So I can put it into GeoGebra. They're already there. I just want to show you what it looks like when we put them in differently. So y equals minus x plus 10 there, and y equals x minus 4 there. And if we look, we're looking for where they cross, and we can see pretty clearly that the solution there is x equals 7, y equals 3. They cross at that point there, 7, 3. One way of doing it. This only really works when it's pretty obvious what the solution is. What if they cross like here? Then it's not so clear. One thing we can do, we can use the calculator to solve it. So I'm going to go in the calculator, I'm going to go to menu, I'm going to go to graph, and I'm going to enter these two graphs here. So minus x plus 10, enter that one, and then x minus 4, enter that one. I'm going to draw it, and then I'm going to zoom. It is a weird thing on these Casio calculators that it won't solve it unless it's on the screen. It's kind of like PS64. So it crosses there, and here you see it's not really all that clear. It looks like it's set 1, 2, 3, 4, 5, 6, 7, but it's not really all that clear. But we can always use gsolve, and we would do intersection, and it finds it automatically for us. X equals 7, y equals 3. Okay, that's one way of doing it. Another way we've got to do it is when it's in this form here, we can use substitution methods. So if y equals minus x plus 10 where they cross, and y equals x minus 4 where they cross, if y equals this, I'll just get the pointer. If y equals this, and y equals this, and y equals y, then where they cross, this must equal this, where they cross. Okay, so I'm going to get minus x plus 10 equals x minus 4 where they cross, which is what we're trying to find after all. And I'm going to subtract 10 from both sides. I'm going to move it up a bit. I'm going to subtract 10 from both sides. So minus x equals x minus 14. And I'm going to take x away from both sides. So minus 2x equals minus 14. I'm going to divide both sides by negative 2. And we find, lo and behold, the x equals 7, which is the same as what we found using the calculator. Now what do? Well, we have our Willy Wonka golden ticket to the chocolate factory here. X equals 7. Wherever we have an x, we're going to substitute it in there to this other equation. So y is going to be equal to x, but x we know is equal to 7 minus 4, and y equals 3. So far, so good. Next way we've got of solving it is the good old calculator. Let's go up here. Like so. There is a special function in the Casio calculators that finds it. So we're going to go across here to equation, EQUA is equation, enter, and it has F1 simultaneous equation solver. Number of unknowns, well, x and y are the unknowns that we're trying to solve for, so there's 2 of them, and as it wants it in this form, some number x plus some number y equals a constant, and they're already in that format. What is the number in front of this x and the y? Well, the number in front of it is of course 1. So 1 plus 1x plus 1y equals 10, and 1x, and then it's not positive 1, it's negative 1y equals 4. And then I'm just going to get to solve it, and it just solves it for me straight away. X equals 7, y equals 3. Same answer. Different method, same answer. So how does the calculator actually do this? Well, let's have a look. I'm going to just go here. I'm going to have the constant. So it was 1x plus 1y equals 10. And 1x minus 1y equals 4. So the way that the calculator solves it, it uses a method called Cramer's rule. Cramer's rule or Cramer's law, and sometimes Cramer is with a K. But here's how it does it. It finds that times that minus this times this. Technically we're finding what's called the determinant. So I'm gonna say x equals, and you'll see why I'm doing this in a second. So 1 times negative 1 is negative 1. Negative 1 times 1. So negative 1 is negative 2. And I'm going to put the negative 2 there like that. Okay, and then I'm going to delete all of that. And here's what I'm going to do here. So I'm going to copy, instead of putting the x there, I want to solve for x, and I'm going to kind of cut and paste this over where the x would have been, or where it was, and I'm going to do exactly the same thing. So 10 times negative 1 is negative 10, negative 1 times 4 is negative 14. Negative 14 over negative 2 is positive 7. It's just a really nifty trick. And I'll leave it for you to do it again for y, but you will get, if we put this on top of where the y is, you'll get positive 3. You'll get negative 6 over negative 2, which is positive 3. Okay, one way of doing it, minus x plus 10, is using Gaussian elimination. X plus y equals 10. And x minus y equals 4. We're going to use Gaussian elimination. So I'm going to say this equation is equation A, the bottom one is equation B. And what I'm going to do, I'm going to choose one to get rid of. They're pretty easy because they're all in lots of 1. I'm going to add A plus B. Okay, so x plus x is 2x, y plus negative y is no y, so that disappears, which is what we want, and 10 plus 4 is 14, so 2x equals 14, x equals 7, and then we're going to go exactly the same as we did before. Substitute x equals 7 in there, so it's now 7 plus y equals 10. I'm going to take 7 away from both sides. Y equals 3. Lots of different ways, but we found the same answer using radically different methods. And it is one of the great things about maths. There's more than one way to skin a cat.